Let's talk about Project 6, Lesson 28. The Louvre Pyramid in Paris, France is built of glass panes. 4 panes are in the top row, and each additional row has 4 more panes than the previous row. Write a series in summation notation to describe the total number of glass panes in n rows of the pyramid. Okay, so our question tells us to write a series in summation notation to describe the total number of glass panes in n rows of the period. So we're describing the total number of panes in n rows of the period. We're writing it in summation notation, and our information is that row 1, they've told us row 1 has 4 panes, and each additional row has 4 more than the previous. So row 2 has row 1 plus 4 panes, right? So row 1 had 4 panes, 4 plus 4 is 8, so row 2 has 8 panes. Row 3 has 8 plus an additional 4, has 12. Row 4 then would have 16 and so on, right? Row 5 would have 20. So each time to get from one number to the next, we're adding 4. And we need to write a series in summation notation to describe this. Okay, so hopefully you watched my lesson 27 video. I go into much more specific and very repetitive detail on summation and series. So here I'm going to keep it a little bit shorter. So if you feel like you need a better explanation of some of these things, go back and watch my last video, which again is much longer, detailed, and repetitive. Okay, but for now, we are going to, again, kind of streamline this a little bit. So already with summation notation, we know we've got this summation symbol, and we need to set our indexes, or indices. Well, if I want to count the total number of glass panes in n rows of the pyramid, so my indices are going to keep track of what row number I'm in. Okay, my indices are keeping track of what row I'm in. And just as a general convention, we're going to start with k equals something to something. Now, I don't know the number of rows, which means I don't know how high to count. And in fact, they even specify n rows. So if I wanted to count all of the rows, all the panes in each row, I'd start with row 1. So I'm going to start from k equals 1, right? And then I would count all the way through all of my n rows. So this summation symbol is telling me that I'm going to take the sum of something that I haven't defined yet, but I'm going to take the sum of something from k equals 1 all the way to n for n number of rows. Now, the series itself, I'm not going to give that away like I did in my last video, but just consider what's happening here. Think about a rule that's happening. So I go from 4 to 8 to 12 to 16 to 20. I'm adding 4 each time. I'm counting in multiples of 4, just kind of consider that. You're welcome to use kind of trial and error to figure out which one is the correct one. I won't say more than that, and we will continue. Now question 2 says, if the pyramid were made of 18 complete rows, how many panes would it have? Now in my last video, I showed you how to calculate this longhand, right? So if you had your summation, I showed you that let's see, I think last time our summation was something like, it would be k equals 1 to, oh, it was 1 to 6. It was n equals 1 to 6 and 4n, right? So we had to take the sum from n equals 1 to 6 of 4n. And I showed you how to do it longhand, and I said this is kind of like another way of saying evaluate 4n when n equals 1, 2, 3, 4, 5, and 6. And then when you take each piece that you've evaluated and you get your answer for each one, then you add all of your results together. That's what a summation means, okay? So this is not the same series that you're using this time, but just, I wrote that down to kind of point out, think about how long it would take. This was just for 6 numbers. What if you had to evaluate it 18 times? You don't, no matter how simple a rule is, you probably don't want to take the time to evaluate it 18 times, so there is an alternate way, which is this. So S sub n, the sum of n, equals n times the quantity a sub 1 plus a sub n over 2. Okay? So a sub 1 being the first number, a sub n being the final number, and then divided by 2. So here's what we do. They're telling us to substitute 1 for k. That answer will be your a sub 1, right? So we know so far that you have the summation from k equals 1 to, because there are 18 rows, we know it's 1 to 18, and then we're going to evaluate that expression, right? And we know there's a k involved. So we're saying, look at your expression, sub in 1 for your k in here. Whatever you get for that becomes your a1, and that goes in right here. Next, substitute 18 for k. So go back to your expression, plug in 18 for your k, and evaluate it. That's your a sub n. That's your a sub n. You're going to substitute 18 for n because that's where your index ends, right? So this will become an 18. Once you've filled in those 3 pieces, you can evaluate, simplify, and that will tell you the sum of n, or in this case that would be the sum of 18, right? So the sum of 18 is equal to 18 multiplied by your a sub 1 plus your a sub 18 divided by 2. Now the actual pyramid has 11 panes less than a complete 18-row pyramid because because no panes cover the entrance. So if we're looking at this pyramid that's made of panes, right? So let's say we've got all these triangle-shaped window panes. The part that covers the door obviously is empty, so no panes go there, meaning we have to account for the 11 that aren't there. So if you knew the total number in the in a normal pyramid, right? So just like a geometric, how many should be in a normal shape, but the Louvre is missing those 11, well then how many does the Louvre have? Okay, so again, we just counted in the last problem the number that a normal geometric pyramid would have. They're saying that this pyramid is missing 11 of those. So what does that bring our actual number down to? And that will tell us the number of panes in the Louvre pyramid.